Yes, I'm back, and I'm complaining about JavaScript yet again, so we may as well get it over with before my doctor calls me and tells me to take my meds again. So, recently I've been starting out with writing a new project called Kahoot. So everybody knows what Kahoot is, basically. It's this game that's often used, it's a web-based game that you play in your browser, and it's basically a glorified quiz. So, I thought, okay, well, this will be a good opportunity not only to do some of my coursework for school, but also an opportunity to teach myself how to use WebSockets and also actually write a full-scale web application without giving up halfway through. And so before I started writing this, I sat down and thought long and hard about what my dependencies are going to be, what my tech stack is going to be, and I actually wrote a design document fully before I even wrote the application. You can see it's 34 kilobytes and counting. We're still writing some of it because I've not wrote the whole project yet. But basically, this is designed to try and be, if we make run, make watch, and then we go to localhost, it's designed to be a sort of Kahoot emulator in Go. So you find a game, you start it, then you join one, and this is obviously all sort of scaffolded. I've not built all of this yet. And then you can see that you pop up on the host screen, and then like if you disconnect, it tells the host you turn red, and then you reconnect, you turn white again. The host can kick you out, and if the host exits, then the game dies. That's basically the whole thing so far. But it loads quizzes from disk in JSON files. The whole thing got off to quite a good start. I'm quite pleased with what I've got so far. And part of the reason I'm so pleased with it is because I sat down and thought very hard about my technology stack that was going to go into it. I essentially decided that the entirety of a quiz can be modelled by a finite state machine, and so I watched a talk by Rob Pike not so long ago called Lexical Parsing in Go about a really clean implementation that you can have of a finite state machine, where basically, if we look at game, there's a type called state func or something. State func, there we go. I'm just going to go to its definition down here, and it's stored as SF in the struct, there we go, state func. And so all it is a function that returns another state func, so it's a sort of recursive definition. And what you can therefore do is you can simply call in a loop, so we set the state func to our initial state func here. We say while state func doesn't equal nil, so we use nil as a sort of sentinel value for we need to end the game. And then we, at the end of each loop's iteration, we set the state func to the value of evaluating the state func. So basically what therefore happens is each of the WebSockets will send some communication over this action channel. We will then perform the action, and then we will update our state accordingly. And so this is how we can have a really clean implementation. This is literally the entire game loop, that's how clean it is, and then you can separate each stage into a subroutine. I'm very pleased with it. And so I've implemented the same thing on the client side. So if we actually count our lines of code here, I need to make my terminal size a bit bigger for people to see. If we count our lines of code, there is quite a little bit of TypeScript actually. There's about 633 lines. There's significantly more JSON for some reason, and there's a significant amount of Go. There's 2,500 lines here or so. And there's 300 lines CSS. In fact, there's almost as much CSS as there is TypeScript. And part of the reason for this is that basically the client code just boils down to a finite state machine, because I hate writing in JavaScript, so I'm using TypeScript that sort of takes the sting away slightly because it makes me feel like I'm using an actually good language, and also because I'm hoping to not write a lot of JavaScript. Hopefully most of it would be declarative in HTML, and that's why I chose to use Alpine.js. If we actually go to their website, Alpine.js dev, we can see basically what this is you put handlers and you put data and you can build components purely in HTML. And it's a very clever way, I think, of creating sort of HTML-ified state. So it's a nice minimal library, and I think it fits well with the look of the rest of my project. And it lets me create a dynamic front end as you need for a game mind, so this is all strictly necessary, I think. And it lets you do it using entirely declarative stuff. The only JavaScript I have to write is stuff that accepts WebSocket connections, and that's it. And the rest of it can be done entirely declaratively in HTML. I'm very pleased with it. But the other day I was looking at my GitHub build times, and I noticed for the most recent build, pulling JavaScript dependencies took a whole 13 seconds. That might not sound like very much until you realize that the entire build, including TypeScript and Go, included just 18 seconds. So if we subtract Go pulling dependencies, maybe that took it about 5 seconds. That leaves us 13 seconds left. So on average, both TypeScript and Go took about 6.5 seconds each to compile their code, versus 13 to download some dependencies. So I thought, God, how much is it pulling? Because I certainly haven't written very much JavaScript at all. I don't know where it's even finding this JavaScript file because I've explicitly disallowed it using Git. It's all in TypeScript. And I thought, okay, it's all going to be in node modules. So if we actually have a look at our disk usage first, front end node modules, we have 115 megabytes of dependencies here. That's, I think, is that 0.115 gigabytes? Getting on towards a gigabyte? It's not an insignificant file size, that. It's quite large, and that is in summary mind. But when you bear in mind that my project has 3 dependencies, let's actually have a look at how many dependencies it pulled in total. So let's ls-la frontend node modules and pipe it into word count-l. We have 357 dependencies. So if we round that up to 360 and divide it by 3, that's 120 dependencies per library that I'm using. Per library. I'm using 2 tools and 1 front-end library. That is it. It's not even like a fully featured framework. It's a thing that scans for HTML tags and modifies data in a text element. Realistically, this should require maybe 2 dependencies for scanning the DOM, and that's it. There's no need at all for anything other than that. The other tool that's slightly heavier than I'd like that I'm using is Snowpack, and basically all it does is it scans through TypeScript files, finds modularized dependencies and copies them into your static site directory. So if we go into frontend static JS, which is where I'm compiling my JavaScript to, we can see that there's a directory _Snowpack, and basically what this does is it has copied all of the required modules into a static file. And it is quite long, but I think that that's much better than using some bundler like Soypack, which is just going to add a bunch of extra code and make it much more difficult for me to write my application the way I actually want it. Ideally, I would just have some CDN downloading Alpine, but I would quite like to be able to actually debug and refactor properly in my in Vim and using standard tools. So basically, I took the slightly cocked option. Like, what do you want from me? It's a big project. So I was thinking, okay, so how many source files actually are there? So I ran find and then node frontend and then node modules, and then what we want to do is we want to find star.js or star.ts. Okay, it's quite a lot. Let's see how many there are. There are 2,287 individual source files inside of the node modules folder. For reference, let's run this on this directory, and let's say let's tell it to ignore so node modules, and let's prune it, and I'm going to have to add -print to both of these now. There are 27 source files in my entire project that are of this nature otherwise. 27. I don't even need the word count directive, I can show you all of them. This is everything. And that's including built files. If I excluded the gen.js directive, there's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 here, so there's actually only 17 source files. And all of them, there's only about 300 lines of code, so all of them are going to be, they must be under 100 lines of code. In fact, most of them are under 50. So, what's going on here? Well, this is another classic case of the, I don't know how to do this, let me search on npm to see if someone else does. Rather than doing what every other programmer in the world for every other language does and goes, hang on, let me have a look on Stack Overflow, see if someone can actually teach me something. Instead, JavaScript programmers download a library and use that instead. Rather than checking, hang on, is there a way that I can reliably check whether something is an array in JavaScript? Instead, they search on npm.org or whatever the hell they're calling it now. They search for is array, they download some library that's probably even a one-liner anyway, and then they search through it. So I actually ran count lines of code on this front end earlier, and this, just for context, this has taken it a significant amount of time to complete. if you look at, for some reason it contains C, I think that's probably a misdetection, but TypeScript, we have, what is that, 148,739 lines of code. Oh, wow, would you look at that? We've hit the million mark for JavaScript, so that's a good sign. Bear in mind, for my entire project, the number of TypeScript is 633. And it's not going to grow much larger than that. Generally, as it's going to grow, I'm going to omit code because I'm just changing it from now, basically. The FSM is in place. I've created a structure for my code. It's all going to work from now on. So, I am pulling literally over a million lines, almost 1.5 million, 1.5 million lines of JavaScript code, just so that I can have 3 dependencies. 3 dependencies. I have more Go dependencies than that, and it's pulling less code. If you don't believe me, I could go and run count lines of code on my entire Go bin directory, and I bet it's only just about that amount of code. And so, to be completely fair, again, for once, this is not the fault of the developers writing this code in full. It's partly the fault of the people who have the attitude of, I don't know how to do this, someone's probably wrote a library for it. But it's also the fault of the JavaScript standard developers, the people who come up with the JavaScript, like, ECMAScript Foundation, or whatever the hell they're called now, or like, the W3C. They've come up with a language that's so over-engineered, verbose, and bloated, that you have to do stuff like, what I'll show you in a minute for this isArray thing, just to check whether something is an array object. In Go, it's literally less than a line of code. It's called a type assertion, and it's not that hard. And, even better, it has static type checking if you know what you're doing. So, I thought that we'd look at some of the hilarious highlights here. And so, remember, I found all of this because I'm starting to exhaust my GitHub build times because pulling the dependencies is taking such a large amount of time. This is taking about 50% of the time. Look, it's taking less time to actually pull the node, binary than it is to pull this JavaScript code. And even so, it's still got deprecated stuff in it. They still can't even manage their dependencies correctly when they're sitting on literally over 1 million lines of code for a simple library. Okay, so if you want a little bit of comedy, because all of the late night comedians these days are terrible, all you need to do is just load up a node modules directory and grep for files which start with is and a dash, and this is actually comedy gold. So, isArray-ish. Let's have a look at what isArray-ish does. Well, first of all, it does a type assertion. It says obj instance of array. Okay, that seems pretty fair. Why is this a library? I don't know. Or array.isArray. Okay, why do we need to do it multiple different ways? I don't know, but let's try another way. Obj.length is greater than or equal to 0. Okay, but what happens if we, because this JavaScript isn't type safe, so what happens if we pass in something that's not an array? I'm assuming that this has sort of C-style order of operations, so if this is false, it doesn't bother to evaluate, but it must do, because it's using OR. So, what happens if we pass a number in? Does obj.length get evaluated? Well, yes, it will probably get evaluated to undefined, which this will be false for. Not very clear, I don't think. Or obj.splice, instance of function. I don't know why we needed to have all of those checks, just to check whether something's an array. So, I think more accurately, this is something more like is iteratable, for instance. But this is a problem that's such more elegantly solved using things like interfaces and contracts like we have in Go, or even that we have in TypeScript. TypeScript has literally solved this problem so much better than this will ever do. This is not type safe, and the fact that this isn't type safe, the fact that this language is so bad, it requires hacks like this library to be put together. And even so, this is such a short thing for a library, and yet they still have unit tests for it. I think that's the other one, actually. There's other ones that made me quite laugh. isNumber. Let's have a look at isNumber. Wow, let's see this. Type of num equals string, and trim doesn't equal a quote. I don't get it. Why are you finding the type of something to be a string when you want it to be a number? The fact is as well, I'm having to read this very, very carefully to try and understand what this even does, because there's obviously no type safety, so I don't know what this returns. Does it return a boolean? Num minus num triple equals 0. Okay, whatever you say, I guess. Type of number equals string, and then you pass a string to something that expects a number? I don't know anymore. This is why I hate JavaScript. The language is so over-engineered that you need hacks like this, isNumber. Seriously? Is this really where we got to? And then this isArray one as well, where they have unit tests for something that's literally checking for one property on an object. Look at this. Look at this. This is a whole library that we're pulling. There's a whole library that we're pulling to check for string equality. I wouldn't be surprised if in the future there's literally an npm package called string equals, which will just convert something to a string and then do a triple equals on it. And that will be the whole library, and there'll be like 5 billion different projects that rely on it. Okay, we have stuff that's actually useful, like is full width code point, which I actually have used an equivalent of this in my Go projects in the past. You know, there is some useful stuff in this. But then we get to stuff that I never asked for and don't know why it's here. So for instance, we have Vue. Why are there Vue libraries being pulled when I'm not using Vue? I'm using a library that I use intentionally because it was minimal and didn't get in my way. It's not a framework, it's a library explicitly. It works with the other tools in your project rather than trying to be all of them at once. I thought that that was what it was anyway too, until I started seeing this, and then I started to realise what I'd done. I'd fallen into their trap. This is what I'm trying to do. There's an interesting thing. Why do I have Amazon Web Services being pulled onto my machine? I don't want Amazon anywhere near my machine, thanks very much, but even if I did, I don't use AWS, and I'm not ever going to use AWS unless I'm paid to do it. Why? What is this? Why do I have AWS 4? See how long this is. It's 373 lines of code. I just don't get it. What is this for? I'm not using Babel either. I'm not using Babel. What is this for? I don't need this. This is my whole point. We're pulling down loads and loads of dependencies that I didn't ask for, that I don't need, that aren't part of the minimal nature of these libraries, that aren't core to development, and that you could definitely exclude if you actually bothered to write your code in a more minimal way. And this is what annoys me. This is going to be left pad over and over again. So, there's a fantastic film that I watched not so long ago, and it's actually from a book that I read a long time ago called The Big Short. And at this point, I'm starting to feel like the Mark Baum character at this film. Like, you've spotted that the entire world's financial system is built up on these terrible loans that are going to default one day. And so, you try to tell people, and no one believes you, and so you just feel like this. And so, these 3 stills from the movie should probably tell you literally everything you need to know about his character. He's played by Steve Carell, and he does faces like this. That's literally all you need to know. I feel like this guy. Try to tell people and don't get listened to, and you basically get told to research what Webpack does by the people in the previous video's comment section. I know what Webpack does, because I was using it and complaining about using it. In the same way that I know what npm does, and I know how many dependencies it pulls for a bloody simple project, because that's what I'm attempting to do. Let's find some more funny ones. Built-ins. If it's built-in, why is it pulled as a dependency, I wonder? I can't even. What is this? Is this library seriously just a JSON file? I wonder sometimes. Okay, CLI spinners. Now I happen to know what this is because I've actually used it in the past. This one's actually quite useful. Big integer. I don't really know why you need to use in a JavaScript library. Like, are we doing supercomputer calculations in our JavaScript libraries now? I'm not entirely sure what big integer is needed for, especially given that JavaScript numbers by default are always floating point and always double precision, so you're practically going to be able to store as many digits as you can possibly need for the accuracy you need at this level. Have a look at some more funny stuff. Tar. I don't even know. I'm definitely not using tar. Puny code. Well, this code's definitely not puny, I can tell you that for a fact. Pump. As if these libraries weren't bad enough already, who comes up with these names? Piffy. Packager. I don't know what this... And this one even has node modules inside its node modules. I wonder how many node modules there are inside of the node modules. That, in fact, I should probably do another find to find that later. In fact, in the pinned comment underneath, I'm going to put all of the statistics I managed to find to complain about. And remember, all the way through this, all of this is being pulled every time. Are we there yet? What an amazing name for a library. Tells me definitely what the library does. At least big integer has a very descriptive name. Chown R, I'm assuming is change own recursive. Istanbul, ignore next. Okay. Buffer util, no idea. I can probably guess, but what is it doing in this JavaScript project yet again when you don't have to manage your memory? Who knows? ES build, I definitely didn't ask for and don't need. I'm not doing any kind of pre-processing with my builder. Literally, I could replace Snowpack with an awk script if I sat down and wrote it and tried hard enough to write it, but frankly, I have enough to do with writing the rest of the project. I just want a quick fix, just for now, at least. In the future, I want to get rid of it, and that's really what I hope to do. Generic names, there's a lot of them in this node module folder, honestly. Oh, this is interesting. Get pass. Now, I can't for the life of me think what this is even for. No, we're not getting passwords in JavaScript. We're not. In fact, this is probably one of those things that's left over from Node, and then when you build for the browser, it doesn't even work. This is another problem with Node.js, where it tries to target both server and client at the same time, and it just doesn't work. For some reason, we have HTTP dependencies inside of our JavaScript. The server is written entirely in Go. There's no need for this. Iconv, Y, everything's in UTF-8. Don't need. Indent string. Is this going to be another one of those one-liners? Is this? Hang on a minute. Is this just left pad? This is just left pad, but where you can right pad at the same time. Oh my god. So, as we can see, the memes have come true. Seriously, just search on just search in your node modules directory for is and then a dash. Apparently an optional dash, because some people can't even do that correctly. This is array one is the good example of a very comedy JavaScript library. Anyway, this was me yet again complaining about JavaScript. The battle has not been won. Finally, when I managed to eliminate Snowpack from this from this project, will it be done? I think we're a bit far away from that at the moment, however. Stop writing libraries like this. Stop being lazy. The node package repository is not a replacement for knowing how to program. And take some wisdom from Mark Baum. If your entire JavaScript stack is based on some really risky, I'm going to start calling them subprime libraries that are eventually going to just fail when the guy maintaining the 2 lines of code decides he doesn't feel like it anymore. The ECMAScript Foundation, or whatever they're called, releases some new breaking change to JavaScript, and suddenly your entire JavaScript stack starts failing, because that 2-line library that you copied and pasted 4 years ago has stopped working properly. Heed this warning. I'm serious. Just you need to, before you sit down and write a project, rather than thinking of the node package repository of like a drag and drop thing that can solve every problem that JavaScript throws at you, and believe me, there will be a lot of problems that JavaScript throws at you. Instead, sit down and think long and hard about what you're going to need and what you're going to use it for before you write a single line of code. Before you write a single JS doc, or whatever it's called, like ECMAScript module import, before you write a single import statement, you think about what it's going to be used for. You think about whether it's going to be used more than once is another important thing. A little copying is better than a little dependency. Guess which man said that again? Hint, it's Rob Pike, yet again. Felt the need to make this mainly because this is sort of driving me up the wall at this point. People make fun of left pad, but they forget that this is a widespread cultural problem in JavaScript. And it's a widespread cultural problem even more in TypeScript, because people who can't be bothered to define types for arbitrary variables they basically just drag and drop them from someone else's project into theirs. So, seriously, heed this warning. Your tech stack is like a Jenga bricks. You should watch The Big Short. Seriously, you'll get a lot of these metaphors. Anyway, that's the end of the video. Rant over yet again.